Hello, my name is Marshall Lisenby. This is my Physics 2 Lab 1, the Charge Tape Lab. The purpose of this lab is to observe the interactions between charged pieces of tape to determine the amount of excess charge on the pieces of tape, as well as how many excess electrons there are on the pieces of tape. And to conduct this experiment, all you need is clear tape, a ruler, support objects, and glow script as the computational model with code to mimic the experiment. So our calculated results are shown here, with 9.33 times 10 to the negative 8 being our calculated charge, and about 5.83 to the times 10 to the 11th excess electrons calculated. And then with the model, we got 1.26 times 10 to the negative 8 coulombs for the charge, and then 7.88 times 10 to the 10 number of electrons on the pieces of tape from the model as well. Now, for the fundamental principles that dictate this lab, we'll talk about three of them. First being Newton's second law / the momentum principle, which states that a system's change in momentum is proportional to the net force applied, or F equals ma. And we use this in tandem with number 3, gravitational force being the attractive force to an object of mass on the Earth, or F equals mg, to calculate the force on the actual piece of tape by knowing its mass and thus the gravitational force on it, which cancel out. And then second being Coulomb's law, the other force in this equation in this scenario, which determines the force of attraction and / repulsion between 2-point charges, and it is F equals 1 over 4 pi epsilon naught times Q1, Q2 being the two charges of both those objects, over r squared being the distance between them, times the unit vector or the direction between those two objects. And that's going to get you the force, or also just the charge of one of the objects times the electric field from the other object. So, for the initial conditions, we have the length and width as measured here, allowing us to calculate the area, the general assumption that a piece of tape is 1 gram per meter, allowing us to calculate the mass, and then the general knowledge that the area of an atom is about 1 times 10 to the negative 20 meters squared, which using the area of the tape and the area of the atom, allowing us to also calculate the number of atoms on a piece of tape. Also, we had to figure out the relative charge of the actual piece of tape, which we did by rubbing a pin against wool, giving it a negative charge, and then placing it near the piece of tape. When we saw attractive forces, we knew that means the pieces of tape have to be positive, which was an important thing to know going into the experiment. Now, getting into the procedure, you can read it here, but essentially we made pieces of U-tape by folding a bit of the ends on themselves and then ripping them off against each other on a piece of table to give it a charge. Then we tested it with a neutral hand to demonstrate attraction, as well as the negative pin, also showing attraction, which we said gives it a positive charge. And then we suspend one of the U-tapes on a box and bring the other one close under it, as demonstrated here. And then once we see separation, once you see part one of the tapes moving, we measure that separation distance, and then we model the tape as point charges and calculate through Coulomb's law, Newton's second law of gravity, the charge of the tape and the number of excess electrons through that. Now, the actual lab experiment is shown here on the right, with tape B, the top tape, being the system, and tape A, the marker boxes in the hand, being the surroundings. And with our actual experiments, we measured the distance, separation distance to be 0.027 meters. With that, we were able to do these calculations demonstrated as below, first calculating the gravitational force and then the electric force as a result of that to get the electric charge, being 9.33 times 10 to the negative 8 coulombs. And then from there, we can calculate the number of electrons by doing and the ratio of atoms to electrons with our numbers provided previously. Now here's my glow script model, a representation on the computer of the actual situation, with my code on the left and the model on the right. The red dot being tape B, the blue dot being tape A, the yellow vector being the electric forces, and the green vector being gravity. Notably, the charge calculated from the model is 1.26 times 10 to the negative 8, about 9 times less than my actual calculated charge. And then the number of electrons on the piece of tape is 7.875 times 10 to the 10, about 10 times less than my actual calculated charge, showing differences that will be explained on the next slide. Now here are some important assumptions and errors in the actual experiment. The assumptions being air resistance, friction, and tension from boxes are all negligible. The long piece of tape is a point charge, and that each piece of tape had evenly distributed charges. All of these can kind of affect our math and the actual situation as calculated. And the errors that are results from this could be actual unequal distribution of charges on each tape not being accounted for, a loss of charge to hand and the environment, as well as the effect of the kind of the neutral hand being present. The net charge not actually being the same for the two tapes, just as a result of the methodology, and then the tension force not actually being negligible in applying some downward force on the piece of tape. Now for some discussion questions. What if electrons had positive charge and protons had negative charge? And what would change about the observations you made with your tapes and other charged objects? Actually, nothing would change at all, because even if the tapes had negative charges instead of positive charges, like charges still repel each other, and the demonstration and the observation would still be the same, as they would still repel and push apart. So interestingly enough, there would not really be an effect from this, as it would be just kind of the opposite dynamic of the same situation. Now, second question. Why is it important to handle the charged tapes as little as possible, and what happens when the charged tapes come into contact with your hands or other objects? So it's important to handle these charged tapes as low as possible, because the charged tapes, having a negative charge, are going to try and neutralize when they come in contact with neutral objects, being they're going to try and regain back the lost electrons that they got from becoming a positive charge, which will diminish their charge and cause a decrease in the effect from the experiments.